Greetings, humans! We're going to be talking about the rules for exponents.
Yay!
I hope your volume was down because I kind of was loud. Here we go. Let's talk about the product of powers property. Here we go. But before we actually introduce the property, I want to talk about a couple of things. Let's think about what 2 times 2 can be represented as. It can be represented as 2 to the second power because you have a repeated multiplication of the same factor. Now, let's think with our brainsicles, and if we had 3 to the 4th multiplying 3 to the second, what does that actually mean? Well, 3 to the 4th is 3 times 3 times 3 times 3. And then we have this little multiplication sign. Oh my gosh, it's like the same signs in between those ones. And we have this idea, which is simply 3 times 3. So what does that equal? I don't know, but I do know that it is 3 to the 6th power.
Yay!
Let's think with our brains a little bit more and see how 3 to the 4th times 3 to the 2nd is the same thing as 3 to the 4 plus 2, which is 3 to the 6th. Gasp. That's crazy. What is going on? Where did the picture go? Okay, if the picture is... Shut up, Jack, please. If the picture is still there, this is the generic representation for the product of powers property. Yay, yay, yay. Okay, here we go. Quotient of powers property. Let's use our brains again. 3 divided by 3. It's simply 1 because you can divide the top by 3 for 1 and you can divide the bottom by 3 for 1. You've done the same thing to the top and bottom, so in essence you've done nothing at all. Nothing at all. Nothing at all. 1 divided by 1 is 1. So cool. Let's take this metaphor a little further. What if we had A times A times A over A times A? That's it. Let's see. Well, if we have the same thing over the same thing, that just simplifies to 1, right? And here's another 1. And here's another 1. So when you actually do the division here and simplify top and bottom, you're left with an A on the top. Let's rewrite this. If we had A to the 3rd over A to the 2nd, that's just the same as saying A to the 3rd minus 2 equals A to the 1, much like up here. Gasp again.
Yay!
I made some room for some more examples. What if we had the example of 4 to the 6th power over 4 to the 4th power? Well, you can either do it a shortcut way, where we take 4 to the 6th minus 4, which would be 4 to the 2nd. Or you can connect with the idea that 4 to the 6th is nothing but 4 times 4 times 4 times 4 times 4 times 4. Or you can connect, and you can connect with the idea that 4 to the 4th is 4 times 4 times 4 times 4. And when you divide these, you're left with a bunch of 1s on the bottom. When they multiply, that's just 1. And on the top, you're left with 2 4s being multiplied, which is 4 to the 2nd, which is 16 over 1, which is just 16. So the rule for the quotient of powers property is simply, if you have something with the same base, a to the n, as long as you have a to some other exponent n on the bottom, you can say a, as long as it's the same base, a to the m, whatever's on top as the exponent, minus the bottom exponent. Bang, bang. Let's combine these two ideas in an all-exclusive example. So if you had this idea, on top, you can quickly add those together using the product of powers property. And on bottom, you can do the same idea. Remember that this right here, single variable, has an exponent of 1, so really it's 1 plus 3 on the bottom. On the top, you've got a to the 8th over a to the 4th. And you can use the quotient of powers property to say a to the 8th minus 4. So a to the 4th is your final answer.